Hi, I'm Fucheng Li.
My name is James Shen.
And I'm Lily Larson, and we are Team 1133. Our coach is Dr. Radu Balan, and we are from the University of Maryland, and we chose Problem C. An overview of our presentation is that we are going to give a brief introduction regarding our problem. We're going to describe the model, the assumption, and its population-dependent probabilities. And we're also going to analyze the results and outcomes of our model. Our model is based on the South Sudan Civil War, which started in December 2013, and the ceasefire was signed in August 2018. There are currently 885,171 South Sudan refugees living in Uganda, and all of these refugees have different beliefs about conflict resolution based on law, practices, and norms, Ugandan law, and international best practices. Our goal was to examine how conflict resolution strategies change over time.
Here are the assumptions of our models. We will assume that there are only three different strategies exist within the camp: arbitration, negotiation, and mediations. We had determined that mediation strategy is the predominant strategy within these settlements. And we also say that mediation is better than arbitrations and arbitration is better than negotiations. And our model is a predator and prey model, with an additional feature that probabilities of converting from one group to another is population dependent. That means, for example, a large group of negotiations should force a small group of mediation to become negotiations. And we also say that population influx is predominantly mediations, as we've seen that the South Sudan refugees mainly believe in mediations as their best practices. And we will also assume there's no outflow of refugees. They will come into the camp and without leaving. Within our models, these are our variables. P of t, which stands for the total populations, is also a model constraint. A total populations within the settlement camp will always be the populations of negotiation plus the populations of arbitration and then plus the populations of mediations. We will include different weights in our models: A1, B1, C1, D1, E1, F1. These are the probabilities of changing from one strategy to the other. As here we see that an example will be A1, and you see there will be an arrow pointing from N to A, and that represents the probability of N converting to A. And R will stands for the rate of population influx in our model. Here are the model constraints. And A1 plus C1s, these are the two arrows that are pointing out from negotiations, and that's equal to 0.45 or 45%. That means the negotiation will stay as itself 55% of the time. And B1 and F1, these are the arrows pointing out from arbitrations. That means there will be a 60% chance of arbitration staying as itself. Similarly, there should be a 70% of chance that mediation will stay as itself, which means this mediation is the dominant strategy. Here are our first iterations of our differential equations without population dependencies. We see that a negative a1 times a times n, this means that the influxes are constrained by the populations of the other groups, because we cannot allow the populations of one group to grow indefinitely. This means that because the populations are a fixed numbers of overall, and r, N, M, and A stands for the proportions of influxes that has the belief of negotiation, mediations, and arbitration respectively. How do we actually account for population dependency is that we will include a term such as a squared and n squared, and make each one of the variables include their respective populations. So therefore, we are seeing square terms in our model. And next, we move on to the results section.
So for our results, we first plotted a no population influx. So we created four scenarios with arbitration, mediation, and negotiation dominant populations, as well as a scenario where all three of them were equal. We found that in each case, the initial population, which was dominant, would continue to be dominant in the long run, whereas the equal population scenario would see mediation dominate and overtake the other ones. We also developed an agent-based model in Logo, which confirmed our numerical analysis here. We next modeled a logistic influx of population, again with the same four scenarios: arbitration, equal, mediation, and negotiation. For three of them, for three of the four, not including arbitration, you can see that the mediation strategy dominates in the long run. However, in arbitration, the AFT is not AFT is not low enough to be overcome by mediation. However, we can adjust the parameters slightly, and eventually we can see that mediation will dominate as well. We also plotted these functions with the logistic influx in NetLogo. We found that these confirmed our MATLAB modeling as well. We next modeled population influx with a variety of models using a linear, exponential, and logistic influx. We found that the logistic influx was best for a number of reasons. First, that the linear model is the constantly increasing section of the logistic curve, and the exponential section is the initial rise of the logistic curve. So both of the linear and exponential are represented in the logistic curve. Also, the conflict in South Sudan started in 2013, but a peace treaty was signed fairly recently in 2018. So once a peace treaty is signed, there would be fewer refugees moving into the camps, which would be best represented by a logistic model.
Other than long-term prediction results of our model, we have also observed an interesting phenomenon in our agent-based learning model. We call this the high-density clustering effect. As seen on the left side with low population density, the population will converge to mediation in a more uniform fashion. The right side with high population density, the mediation group will form a cluster first and then spread outward. This leads to, in the high population density case, it requires a smaller percentage of mediations, less than 20%, to convert the entire population to use mediation. In order to account for clustering in our model, we have made a change to our weight. The weight will decrease over time through a sigmoid function. This decrease in weight will mean a higher probability for an individual to keep its strategy. The result, as shown at the right, n prime t and m prime t with clustering effect will converge quicker. We believe that this phenomenon will also be reflected in the real world because refugee camps are usually densely populated.
Some future improvements for our model would be that we could choose a different base function to model with. So we can use like a sinusoidal function, which has multiple peaks of influx, as opposed to ours that only really has like one. And a small population of negotiation and arbitration can be maintained because right now in our functions, the negotiation arbitration groups die out and then they have a population of 0 eventually. And we could also use a better metric to measure the dominance of strategy. And we can also change like the dominance of strategy over time. So for example, arbitration can be dominant at one time, but then negotiation can be dominant later. In conclusion, we developed a predator and prey Diffie-Q to predict the dispute resolution among refugees. Real-life refugee influx was best represented with a logistic model. The long-term strategy chosen from our model is mediation, and clustering effects will affect the system behavior above a critical value. Thank you for listening to our presentation.